Okay, this video clip is on section 2 of light, and this is the electromagnetic spectrum. As we learned in the last chapter, or last section, all EM waves travel at the same speed in a vacuum, and that rate is 300 million meters per second, and that includes light. The reason for this is because, as we learned in the equation, wavelength times frequency equals speed, that if the wavelength increases, frequency decreases, and vice versa. The electromagnetic spectrum is made of 7 types of electromagnetic waves. They range from the longest wavelength to the highest frequency, and they are radio waves, then microwaves, then infrared, then visible light, then ultraviolet light, then X-rays, and then gamma rays. If you look at the picture here a little bit, you can see the different sizes of the waves. So again, the longest wavelength and the lowest frequency to the highest frequency and the lowest wavelength, and these here have the most energy. The first one is the radio wave, and as I said, this has the longest wavelength and the lowest frequency. The wavelengths can be longer than 30 centimeters. You do not need to know these numbers, but you do need to know some of the examples that go with it, and these all were part of our drawings that we did in class. AM and FM radios and television signals, again through the antenna, are all using radio waves. And AM is amplitude modulation, and this one bounces off the atmosphere so it travels farther. FM is frequency modulation, and this one is less affected by electrical noise, so you get better sound quality. When we're talking about an antenna in TV pictures, again, the picture is sent through the AM wave, and the sound is sent through the FM. The second type is a microwave, and now the wavelengths are getting shorter, and the frequencies are starting to get higher. This would be in your microwave oven, your cell phone, a radar like a police radar here, and we can also use it in like shortwave radios and things like that because it sends the information over long distances. And basically the police radar is kind of like echolocation. It sends out a signal by the gun and it reflects off the car and returns to the gun. The third one is infrared. Infra means before, so it's before red. And here, this would be anything that your body uses to detect infrared radiation, which would be like an infrared camera. Also, a night vision goggles would fit here. Heat lamps, remote controls, all have that. So just a couple quick clips here. This one here is showing night with the night vision here. It's picking up the body heat. So this would be like if you watch the show Cops, things like that, when they're showing the police helicopter going over Los Angeles and things like that, chasing a criminal at night. Okay, the second one here is from an old movie called Predator that we watched in class, and this one here is using the infrared camera, and this is how the Predator was able to see. And I'll kind of fast forward through some of this so you can see where where the infrared is at.
You're a rescue team, not assassins. Now, what do we gotta do?
In a part of the nothing that lives is safe.
You lose it here.
An elite rescue squad
You're bleeding, man. I ain't got time to bleed.
is being led by the ultimate warrior.
We need the best. That's why you're here.
But now,
What's got Billy so spooked?
there's something out there waiting for us. And it ain't no man. They're up against the ultimate enemy.
Holy Mother of God.
Nothing like it has ever been on Earth before.
She says the jungle just came alive and took her.
We cannot see it. Pleasure.
He was skinned alive.
It hunts for sport.
He's killing us one at a time. We're all gonna die.
But this time, it's picked the wrong man to hunt.
If it bleeds, you can kill it.
Century Fox presents Arnold Schwarzenegger. Predator. The hunt begins Friday, June 12th at theaters everywhere.
Okay, so would be a lot colder. So this is infrared. So far we've talked about radio waves, then microwaves, and then infrared. Well, the next section then would be visible light. And this is the only part of the electromagnetic spectrum that we can see. Again, white light, rainbows, the sun, flashlight, anything that produces white light fits here. And the word that you need to remember here is Roy G. Biv. And this is the colors of the spectrum: red, orange, yellow, green, blue, indigo, and violet. And these are the colors in order that you should know. So just make sure you do. Indigo is kind of a dark blue, and then violet would be like purple. Again, in this here, red, because it's first, has the longest wavelength, and violet, because it's last, has the shortest wavelength. So when you're looking at a rainbow or light through a prism, it breaks it down accordingly to the longest wavelength, because it diffracts or refracts the least, and then violet refracts the most, so it would be, that's where you get that color. So again, visible light is the only part of the spectrum that we can see, and again, the colors that you need to remember are Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. The next one going along here now is ultraviolet. Ultra means beyond, so it's just beyond violet. And this again are waves that are produced by the sun. Ultraviolet light is both good and bad. It's good because it does destroy viruses and bacteria on foods and surgical instruments. It also stimulates our body to produce vitamin D and give us healthy bones. The negative is that it can cause sunburn, wrinkles, and skin cancer. And a couple other examples here would be like using a tanning bed, or in this picture here, this would be an example of skin cancer. To help us deal better with the sun, we use sunscreen, and the higher the SPF that you have, the better it is. Buying sunglasses that block out ultraviolet radiation, both A and B. And then again, if you're out in the sun a lot, like in the boat for long periods of time during the day, wear long pants and long sleeves, so you don't look like this kid here, or when you get older, you don't look like this lady here, whose skin is very wrinkly and almost to the point of looking like leather. Getting higher frequency now. These are now our X-rays, and this is the first type of electromagnetic wave that can actually travel through matter. And again, we think of, in the medical field, an X-ray machine taking pictures of your bones, and then also in airports, public buildings, they still use those in certain circumstances to see what's found, or see what's inside of you or on you when you're going through the airport detectors. Again, if you go to the dentist or get an X-ray of your broken bone, a lot of times they will put a lead apron over you to protect your body from X-ray radiation. And then the last one are gamma rays. This is the highest frequency of all waves. It's the most radioactive because it also has the most energy. This type of wave can penetrate most materials very easily. An X-ray penetrates soft tissue very easily, but not harder tissue like a bone, whereas a gamma ray can easily go right through that. Again, good and bad here too. Good, it is used to treat cancer, but along the same line, it can cause cancer. It kills harmful bacteria in fresh meat and fresh fruit, so it's safe for you to eat. It's found in nuclear power plants, and as I said, the negative is that it also kills living cells. Also found in the atomic bomb, and again, here's a picture of Byron. So again, just kind of going through these really quickly, the electromagnetic waves travel at a rate of 300 million meters per second. They all travel at the same speed, and they go from the highest wavelength or longest wavelength of radio, then microwaves, then infrared, then visible light, then ultraviolet, then X-rays, and then gamma rays. And gamma rays have the highest frequency and the shortest wavelength. So make sure you know them in order for the test. And then the next one will be on section 3.